And after that, what we've done is, so actually after we calculate the equivalent, uh, this what we say as equivalent magnitude of the rank, we have actually normalized the matrix, and then this is the normalized matrix you see, and then we start to develop the concordance matrix for the criteria flow, criteria head, and criteria financial liability, right? And how we have done it, I have already discussed about that. I will not discuss multiple times because it will only make the video lengthy. So this way, they have done if A is greater than B for the criteria, then the concordance index is constituted with the weight of that criteria. If not, 0 is assigned for that. In this way, for flow, head, and financial liability, we have calculated and ultimately developed this concordance index. So, which is actually the uh, summation of all the weights of the criteria for the comparisons for which uh, uh, the comparison is true. That means if I am asking A is greater than B or not, it is A is greater than B. So that weights is added to index, concordance index, and accordingly, uh, all the weights for which of all the weights of the criteria for which the comparison wins is added, and is that makes the concordance index, right? And for discordance index, what happened? For discordance index, if the A is less than B, here we talk about less than B, not greater than B. If A is less than B, then we calculate the difference between A and B and divide it with the maximum difference that exists between the alternatives for that criteria, right? So that will give you the value in the discordance set. And accordingly, we have done that for flow. Accordingly, we have done that for flow, head, and financial liability. Ultimately, we have developed the discordance index, where the maximum value of discordance index for the criteria flow, head, and financial liability is taken as the value of the discordance index. Once this is done, we try to find the rules of the strong outranking and weak outranking. For strong outranking, the concordance index between two alternatives must be greater than the strong concordance uh, value and must be less than the discordance index of that same two alternatives must be less than the strong discordance value, threshold value. And the alternatives weakly outranks each other if the concordance index value is greater than or equal to the weak concordance value, and the discordance index value of the same alternative is less than the weak discordance value. Now I have discussed how the strong and weak concordance and discordance values are calculated, threshold values are calculated. That I have already discussed. There are two methods, data driven and one is data driven, and this is judgment based. And in case of data driven, we average all the concordance index value for all the comparisons and then add a fraction to it to determine the strong concordance threshold value, and the average becomes the weak concordance threshold value. In case of discordance index also, we average all the discordance index value for all the comparisons, and what we do is we we mm, add a certain function, certain fraction to that, and if our discordance index is less than that discordance value, that becomes strong discordance, strong outranking by discordance. And for weak, we keep the average discordance as the weak discordance threshold. So that is the way for data driven. In case of judgment based, we add the concordance index value and take the 70% or 60% of that as strong and weak concordance threshold value respectively. Same thing is done with the discordance index also. Discordance index, we add them, and here in this case we take the 100% of the addition as the discordance threshold, or 70% of the addition, that's the total value, as weak discordance threshold. The rule is, if strong outranking is there, strong concordance, then the concordance index value of the alternatives must be greater than strong concordance threshold value, and discordance index value of the same alternative must be less than the strong discordance value. For weak, just replace the strong concordance and strong discordance value with the weak concordance and weak discordance threshold values. That is all. So in this way, we can develop the outranking matrix. This is the outranking matrix. And with the help of this outranking matrix, we classify the alternatives into different classes based on the rules of descending and ascending distillation. In case of descending distillation, we go from best to worst. That means we assign the highest scored alternative to the best class and lowest scored alternative to the worst class, and all other alternatives stays in between them. This is descending. And for ascending, we assign the best class to the lowest scored alternative and the worst class to the highest scored alternative. If an alternative is member of the best class in case of descending and worst class in case of ascending, then that alternative is the most preferred alternative with respect to the ELECTRE II method. In our example, that was score B, alternative B. So you can develop a hydropower plant in the location B. So that is all I have to tell today. I think you have understood ELECTRE II. If you have any question, I will request you to comment them. And if you like this tutorial, please subscribe to my channel, and of course like and share my videos. And if you want to be alerted whenever I post a new video, then click on the bell icon. And yes, do not forget to hype, give me hype marks such that I can rank higher and more student gets benefited by listening to my videos. That is my only goal. Thank you and see you soon. So to the worst position alternative. So worst positioned alternative with respect to score is A here. Then next, little better than A is B, C, 0 score, and the best here is actually with respect to score is B. But here, as per the rule, class 1 will be assigned the worst alternative A, and the class 3 will receive the best alternative. So don't get confused. First, assign score based on outranking. Strong outranking will get more score compared to weak outranking. And if there is no outranking, just give 0. Okay. After you assign score to all the alternative for all the situations, situation means all the comparisons. Okay, A versus B, B versus A, and so on. You add them for each of the alternative. Now, with respect to score, you rank them. The highest rank get rank 1, followed by the other alternatives. And the worst, the alternative with the worst score among all the alternative get the lowest rank. In our case, it is 3. Now, when you are arranging them in with respect to the ascending distillation, the worst ranked alternative will get the best class, that is class 1, and the best ranked alternative will get the worst class, that is class 3. So that is why it is ascending. It is coming from worst, which is the class 1, to the best, which is the class 3. But in case of descending distillation, a normal thing follows. The best alternative is assigned the class 1. Worst alternative is assigned the class 3. So here this class is actually representing that we from class 1 is the best, class 3 is the worst, so we are going from best to worst. So after that, if you compare this ascending and descending distillation, what you find is, in case of the descending distillation, which is a normal scenario, because the alternative with the maximum score gets the best rank and also the best class, that is the class 1. That same alternative has got the worst, sorry, has got the worst class in case of ascending distillation, which is worst to best. Means worst class means here class 3. Class 1 is the best with respect to class, right? But in case of descending distillation, we are following from best to worst. So the best will be that one which has the highest score. But in case of descending worst to best, the best alternative with highest score will get the worst class. That is the difference. If it is 2, if the same alternative get the worst class, worst class, class 3 for ascending distillation, and best class, class 1 for descending distillation, then that alternative outranks the other. And the alternative which is in between them, for both descending and ascending distillation, it gets class 2, which is the medium, right? Which is the medium, neither good, neither best. So it cannot outrank the class 1, outrank the alternative which gets the best class for descending and worst class for ascending. So it cannot outrank that, and it can outrank that class which has get the worst class in descending and best class in ascending, right? So that way, uh, this alternative is placed into the middle. So, uh, so that is the way electric spots the most preferred alternative. So you see, the entire method is very easy except the last 2 step, which is a little bit confusing. So ascending distillation and descending distillation, here you just remember, in case of ascending distillation, we are going from worst to best. That means worst is assigned the best class. Here class 1 is represent the best class and class 3 represents the worst class and class 2 is in between them. So in case of ascending, the worst scored alternative is assigned the best class and the best scored alternative is assigned the worst class. But in case of descending distillation, the situation is just opposite. The best scored alternative is assigned the best class, worst scored alternative is assigned the worst class. This is different. And what we check is that if this is exactly the case, the best, the alternative which has the which become the member of the best class in case of descending distillation and the member of the worst class in case of the ascending distillation, that alternative wins the game and becomes the most preferred alternative for the decision maker. In this case, our case, it is the alternative A or location A. Thank you. This is what you know as ELECTRE II. If you have any question, you can ask in the comment. I'll be happy to answer them. But more or less, this is ELECTRE II. It is a little bit longer. The method is a bit longer, I will say. And let us still recapitulate the entire procedure again. Start, define alternative and criteria. We defined it. Set criteria weights. We have given the criteria weights. Here you see. This is the criteria weight. We just assigned it. And alternatives are ranked as per their values. And for the criteria, if the criteria is beneficiary, then we ranked it the best as the best rank, first rank, and so on. And if it is a penalty criteria, cost criteria, the lowest value is assigned the highest rank, right? So after then we have converted them into magnitude, because as you know, the rank as a magnitude doesn't represent the exact, the real picture. So we convert them into its equivalent magnitude.